to this video lecture on transportation problem part 1. In this video lecture, we are going to discuss about introduction about transportation problem and different initial basic feasible solution procedures to solve the transportation problem. First, what is transportation model? It is a special case of linear programming problems that deals with transporting a commodity from sources to destinations. There will be a single commodity available and there are various sources and various destinations. Our job is we have to transport that particular single commodity from various sources to various destinations so that the total transportation cost is minimum. So the objective is to determine the shipping schedule that minimizes the total shipping cost while satisfying supply and demand limit. We assume that the shipping cost is proportional to the number of units shipped on a given route. And this is the exact representation of transportation problem. Here we will be having so many supply sources. And these are all the demand locations or destinations. And this A1 to AM, this represents, if it is AM, this represents availability from source M. And the same way, B suffix N represents demand required by the destination N. So there will be M number of sources and N number of destination available. And this we have C11, X11 to CMN, XMN. Here CMN represents cost to send a single unit of the particular commodity from M source to N destination. And this XMN represents number of units to be transported from the source M to destination N. This is the representation of transportation problem. And the same thing can be represented as general LPP, that is linear programming problem like this. So here we have to minimize the total transportation cost. Subject to the conditions, there are some availability from various sources like 1 to M, and there are requirements at various destination, which is called as B1 to BM. And here decision variables should be greater than or equal to 0. This is the general form of LPP. General transportation problem form of LPP. And here the availability at sources I is AI, which is I is equal to 1 to M. This is I is equal to 1 to M. And demand at destination J is BJ, B suffix J, where J is equal to 1 to M. So this is that. And cost of shipping 1 unit from destination source I to destination J, which is CIJ. This is CIJ. And there is no need to write the LPP like this, which consists of objective function equation and constraint equation. For that, so usually it is not necessary to explicitly build the LP model of the transportation problem. Instead, we usually represent the transportation problem by using a transportation table like this. So here you can see the destination. There are N number of destination, and here there are M number of sources, and the demand from each and every destination is arranged here B1 to Bn. The same way supply from each source is also arranged here A1 to AM. Here the cost for the particular transportation is available in the matrix form. For example, if it is C22 means this is the transportation cost required to ship or transport a single commodity from the source 2 to destination 2. Next comes the solution procedure. First thing is we have to formulate the problem and arrange the data in matrix form, what we have discussed just now, and we have to balance it. What do you mean by balancing? If the total, we'll see in the next slide. What do you mean by balancing? We'll see it in the next slide. Next, second step is we have to obtain an initial basic feasible solution by using one of the three procedures. First procedure is called as northwest corner method. The second one is least cost method, and the third one is Berger's approximation method. Here, we can use any one of the method to find the initial basic feasible solution. If it is specifically mentioned, we have to use only the particular initial basic feasible solution procedure to solve the transportation problem. Otherwise, I advise all of you to follow or to use Berger's approximation method to solve the transportation problem. Then we can just move on to the optimization solution procedure, because the Berger's approximation method will give near optimum solution, so that there will be number of steps will be reduced in the optimality procedure. So I recommend Berger's approximation method if it is not specifically given to find out the initial basic solution for the particular transportation problem. And after finding out the initial basic feasible solution, we will be getting number of positive allocations, and that number of positive allocations must be equal to m plus n minus 1, where m is the number of rows and n is the number of columns of the particular matrix what we have formed just now in the previous slide. After obtaining the initial basic feasible solution, then we have to find the optimum solution by using a different method that is called as modified distribution method. In short, it is MODI method. Other name given for this modified distribution method is UV method. So it is actually a two-step procedure. First one is we have to find out the initial basic feasible solution by using one of the three methods. Then that positive allocation should be used for finding out the optimum solution by using MODI method. Next thing is balancing the transportation problem. So balancing means always the total supply must be equal to total demand. If it is not the case, that is actually called as unbalanced transportation problem. If it is not equal, that is, there may be two cases. One is total supply may exceed or total demand may exceed. If total supply exceeds total demand, a dummy destination whose demand equals the difference between the total supply and the total demand is created. And similarly, if the total supply is less than total demand, a dummy source is created whose supply equals the difference between the total supply and total demand. So after creating the dummy destination or dummy source, a unit shipping costs into a dummy destination or out of a dummy source are 0. We have to assign 0 value for all the cost values of the particular dummy destination or a dummy source. An example is given here. Here you can see. So there are 3 sources and 4 destinations, and this is the unit cost matrix of the transportation problem, and the supply is given as 12, 17 and 11 from the sources S1, S2 and S3, and demand are given as 15, 10, 15, 10 from the destination D1, D2, D3 and D4. If we just sum it up, the total supply will be equal to 40, right? If we just sum the demand, it will be 50. So total supply is equal to 40 and the demand is 50. So it is not balanced. We have to make it as balanced by adding a dummy row which contains 10 supply units and here all the cost values will be 0. This is how we have to add the dummy row or dummy column to make the particular problem as balanced one, right? This is actually the first step. First thing is we have to check whether the particular problem is balanced or not. If it is not balanced, we have to balance it by by adding a dummy row or dummy column with 0 cost units. Next comes the initial basic feasible solution. The first method of finding the initial basic feasible solution is northwest corner method. First we will see the procedure, then we will move on to the example. So this method starts at the northwest corner cell, that is left topmost cell 1, 1. Here we have to allocate as much as possible to the selected cell, and then we have to adjust the supply and demand accordingly. Then one of the column or row will have 0 value. If a row or column is having 0 supply or demand, we have to just cross it out, and if both the row and the column are simultaneously satisfied, then cross out both. Then if no further allocation is to be made, stop, else move to the cell to the right or the cell just below if a row has just been crossed out. Otherwise, go to step number 1 and repeat the same procedure until further allocation is to be made. This is the procedure to be followed to find out the initial basic feasible solution. And now let us look into an example. So this is a given problem. We have 3 sources, 4 destinations. We have supply values and destination values, and this is the cost matrix. First we have to check whether the particular thing is balanced or not. The total supply is 5 plus 2 plus 3, which is 10. Total demand is also 10. So it is a balanced problem. We have to move on to the next step. So in the northwest corner method, first we have to choose the northwest corner cell, which is the 1, 1 cell, left topmost cell. So this is the particular cell, and we have to allocate as much as possible in the cell. If we just consider the corresponding demand, it is 3 units and the supply is 5 units. So here we can just allocate maximum of 3 units in the particular cell, because the demand is only 3 units, even though there are 5 units of supply available, but the demand is only 3 units. So we can just allocate as much as 3 units here, like this. And we have allocated 3 units here. So the remaining demand will be 0 and remaining supply will be 2 units here after allocating 3 units of demand here, alright. So here there will be only 0 remaining units. We can just cross out the entire column. Then after doing this, we have to move on to the next northwest corner cell. In the remaining matrix, the next northwest corner cell is this one. So we have to allocate as much as possible here. The supply is 2 units and the demand is 3 units here. So we can allocate only maximum of 2 units here. And the remaining unit is 0 here, and here it will be 1 unit remaining. So we can just cross out the entire row like this. Then this is the remaining matrix. We have to look for northwest corner cell in the remaining matrix. This is the northwest corner cell in the remaining matrix. Here we can allocate as much as 1 unit, and the remaining unit is 0 here, and here the remaining unit will be 1. So we can just cross out the entire column also because of the 0 demand availability here, right? Next, this is the remaining unit. In this remaining unit, the northwest corner cell is this one. So here we can allocate only 1 unit. So the remaining unit will be 0 here, and here the remaining unit will be 1. So we have to cross out the entire row. So wherever there is a 0 supply or demand, we have to cross out the particular row or column. This is actually the remaining matrix. This is the northwest corner cell. So here we can allocate only 1 unit. So 1 unit, and the remaining unit here is 0, and here the remaining unit is 2, and here we have only 1 cell left, and we can allocate 2 units, and the remaining is 0 demand here, 0 supply here. So this ends the iteration process. And this is how we have to allocate and find out the initial basic feasible solution by using northwest corner method. Now we have to find out the transportation cost. Transportation cost is, or total shipping cost is, this is the cost, and this is the number of units to be transported using the particular source and destination. So it is 3 into 3 plus 7 into 2 plus 4 into 1 plus 3 into 1 plus 8 into 1 plus 5 into 2. So total is 48 rupees. So this is how we have to calculate the initial basic feasible solution and the total transportation cost associated with it. This is by using northwest corner method. Next comes the least cost method. The other name given to this least cost method is matrix minima method. Here comes the procedure. Here, instead of starting from the northwest corner cell, we have to start with the cell which is having least unit transportation cost. And after choosing the particular cell with least unit transportation cost, we have to allocate as much as possible. And we have to repeat the procedure as it is in the previous one. If there is 0 supply or 0 demand, we have to cross out the particular row or column. And if both the row and columns are simultaneously satisfied, we have to cross it out. And we have to look for the uncrossed out cells with the smallest unit cost and repeat the process until no further allocations are to be made. We will explain it with an example. 3 sources, 4 destinations, supply is given, demand is also given. We have to balance it, first thing. So total supply is equal to 10, demand is also equal to 10. So it is a balance problem. We can just proceed further. So this is actually the unit matrix. Here we have to choose the least cost. So we have 2 least costs, 2, and here also there is a tie between the least cost, right? So we have 2. We can just choose either. I'm just choosing this. And the allocation, maximum allocation possible is 2, because here the supply is 2 and the demand is 3. So maximum allocation possible is only 2 units. I'm just allocating it. And the remaining supply will be 0. And here the remaining demand will be 1 unit. So just we can cross out the entire row because of the 0 supply, like this. Then in the remaining matrix, we have to look for the least cost again. Again, there is a tie between this cell and this cell, which has least cost, which is 3. We can choose either. I'm just choosing this. Here we can just allocate 1 unit. And the remaining unit will be 0 here, and here it will be 4. And 0 demand, so we can just cross out the entire column like this. Then in the remaining matrix, we have to look for the least cost. The least cost is 3. And supply is also 3, demand is also 3. So we can allocate as much as 3 units here. and the remaining supply is 0, demand is 0. So we can cross out both the row and column like this. And these are all the 2 remaining cells. Among this, 4 is the least cost. We can allocate as much as 2 units here, and the remaining demand is 0 and the supply will be 2 units, and there is only 1 remaining cell, so you can directly allocate that. Here we can allocate as much as 2 units, and the remaining supply will be 0 and the demand is also 0. So this is how we have to allocate this, and the allocations are 1 unit in this cell, 2 unit in this cell, 3 unit in the particular cell, 2 unit in the particular cell, and 2 units in the particular cell. And the transportation cost will be multiplication and summing up all, that is 3 into 1 plus 2 into 2, this comes like this, 3 into 1 plus 6 into 2 plus 4 into 2 plus 2 into 2 plus 3 into 3, which gives 36 rupees. So this is procedure of least cost method. We'll solve one more example using the same least cost method. We have 3 plants A, B, C, and 2 markets 1 and 2. Supply is given, demand is also given. First thing is we have to balance it. So 2300 plus 1400, so it is 3700. Here also it is 3700, so it is balanced problem. Then after balancing it, we have to look for the least cost. Least cost is 68, and we have to allocate as much as possible here. Here 1200 supply and 1400 demand. So 1200 units can be allocated here, and the remaining unit here is 200, and here it will be 0, and we can just cross out the entire row. Then we have to look for the least cost among the remaining matrix. Here it is 80, and here we can allocate 1000 units, and the remaining will be 0 supply and 1300 units of demand. So we can cross out the entire row because of the 0 supply, and there are 2 remaining cells. Among this, 100 is the least cost, and 1300 can be allocated here, and the remaining will be 0 here, and here it will be 200. There is only 1 cell remaining, so we can allocate as much as possible here. So we can allocate 200 units here. So this is how the remaining will be 0 and 0. So this is how we have to find out the initial basic feasible solution by using least cost method. And if you just calculate the total transportation cost, will be 3,13,200 rupees. If you just multiply it and sum it up, you will be getting it. Next is the third initial basic feasible solution procedure, which is very efficient one, which will give near optimal solution. So I strongly recommend to use this Virgil's approximation method or VAM to find out the initial basic feasible solution if it is not specifically mentioned in the problem, right? So first thing is we have to determine the difference between the lowest 2 cells in all rows and columns including dummies, right? Then we have to identify the row or column with the largest difference, and if there is a tie between that 2 difference, we can just choose either. Then allocate as much as possible to the lowest cost cell in the particular row or column which is having the highest difference. If 2 or more differences are equal, allocate as much as possible to the lowest cost in these rows or columns. Then start the process if all row and column requirements are met. If not, go to the next step. That is, we have to recalculate the differences between the 2 lowest cell remaining in all rows and columns. Any row and column with zero supply or demand should not be used in calculating further differences. Then go to step number 2 and repeat the procedure again until all the rows and columns are satisfied. We'll see an example for this. 3 sources, 4 destinations, supply and demands are given. First thing is we have to balance the problem. We have to check whether it is a balanced problem or not. Total supply is 10 units and total demand is also 10 units. So it is a balanced problem. We can just proceed further. First thing is we have to calculate the differences or the penalties of row and column. Here if you just consider the first row, we have to choose the which one? Here you can see that we have to determine the difference between lowest 2 cells. Okay. The lowest cell in the first row is, lowest cost cell in the first row is 3 and the next lowest is 4. So we have to find out the difference between the lowest cell and if you just leave that in the remaining, what is the lowest? We have to choose that too and calculate the difference. So it is 3 minus 4 which is 1. The same way calculate the penalty or the difference for the second row. The lowest cost is 2 and if you just leave it in the remaining, again the lowest cost is 2. So 2 minus 2 will give you 0. This is a row penalty. And the next row is the lowest cost is 3. If you just leave this in the remaining, the lowest is 4. The difference between 3 and 4 is 1. So likewise we have to calculate the row penalties. The same way we have to calculate the differences or the column penalties. Here in the first column 2 is the least cost and the next if you just leave this and in the remaining 3 is the least. So difference between 2 and 3 is 1. The same way here the difference between 3 and 4 1. Here the difference between 3 and 6. So it is 3 and in the next column the lowest is 2 and next to the lowest is 4. So difference between 2 and 4 is 2. Alright. So this is how we have to calculate the row penalties and column penalties. After calculating all the column penalties and row penalties, we have to choose the largest number among this, largest penalty, right? The largest penalty after considering all these 7 differences is 3. So we have to choose this and we have to choose the corresponding column or row. Here it is column, so we have to choose this column and in this column we have to choose the least cost again. So this is our least cost. After choosing the least cost, we have to allocate as much as possible here. So this is the least cost and here the supply is 2 units, demand is 2 units. So we can allocate as much as 2 units possible, right? And the remaining supply is 0 units, demand is also 0 units. So we have to cross out the row and the column, right? And again we have to recalculate the row penalties and column penalties for the remaining matrix. So if you just consider the first row penalty will be 3, 4. Difference between 3 and 4. So it will be 1. Nothing can be calculated here. And for the third it is 3 and 4 again. So 1. Column penalty, here the difference between 3 and 4, so it is 1. Difference between 3 and 7, so it will be 4. Here no penalty can be calculated. Next is difference between 4 and 5, 1. So after calculating this second sets of row penalties and column penalties, we have to choose the highest among these penalties, right? The highest among these penalties is 4. So we have to choose a particular column And in the particular column, we have to choose the least cost. So least cost among these two is 3. So we have to allocate as much as possible here. So we can allocate 3 units. So the remaining supply is 0 and demand is also 0. So we can just cross out both row and column. Right? And we have only 2 left out cells. So there is no need to calculate the penalties. We can choose the least cost among these two. So the least cost among these two is 3. So here we can allocate 3 units. And the remaining supply will be 2 and the demand will be 0. And there is only 1 cell left. So here we can allocate 2 units. And the remaining will be 0 and 0. Here also it will be 0, right? Okay. And the total transportation cost will be 3 into 3 plus 4 into 2 plus 3 into 2 plus 3 into 3. So it will be 32. So this is how we have to calculate and find out the initial basic feasible solution by using Burger's approximation method. As we already discussed, Burger's approximation method is the best method to find out the initial basic feasible solution because it will give near optimal solution. So while performing optimality iterations by using Modi method, the number of steps will be reduced if you use VAM method. So next comes the assignment problem. There is a company which has 3 production facilities S1, S2 and S3 with production capacity of 7, 9 and 18 units which is given in hundreds per week of a product respectively. These units are to be shipped to 4 warehouses D1 to D4 with requirement of 5, 6, 7 and 14 units which is given hundreds per week respectively. The transportation cost in rupees per unit between factories to warehouses are given in the table. Find the initial basic feasible solution by using all 3 methods. Northwest corner method, least cost method and VAM. If we just solve this and find out the initial basic feasible solution, it will be very clear by using all these 3 methods. Thank you for your patience hearing. In the next video, we will see how to calculate and find out the optimum solution by using the initial basic feasible solution obtained from these 3 methods by using modified distribution method. Thank you.